Exercises of Chapter 7, the Chemical Kinetic. Exercise 23, I will change the order of the exercises. The unit of the rate reaction is mole liter minus 1 second, mole liter minus 1 second minus 1. We have several proposals, or E depends on the reaction partial order. For a reaction, the simple reaction from A to product, the rate of the reaction is defined as the rate of disappearance of A. And the rate of disappearance of A can be expressed RA equal minus DNA, the variation of the number of moles of A per dt, or the rate of A can be expressed as the variation of the concentration minus dA divided by dt. So the rate of the reaction, the unit is mole per time or molar per time. The rate of the reaction, the unit of the rate of the reaction is independent of the order. So the unit is always mole per time or molar per time. Molar means mole per liter. So the correct answer is B. Exercise MCQ exercise 24. Consider the following reaction: dichromate, H plus iodide to give chromium, iodine, and water. Which of the following statements concerning the reaction is correct? In the statements A, B, in the proposal A, B, C, and D, we have relation between the rate of disappearance and the rate of formation. To note that the rate of the reaction is related to the rate of disappearance of reactants and the rate of formation of the products according to the stoichiometry. And pay attention, this relation should be applied at the same time t for all reactants and all products. So the rate of the reaction equal the rate of disappearance of dichromate divided by 1 equal the rate of disappearance of H plus divided by 14 equal the rate of disappearance of I minus divided by 6 equal the rate of formation of chromium 3 plus divided by 2, the rate of formation of I2 divided by 3, and the rate of formation of H2O divided by 7, and this relation should be applied at the same time t. So in the answers, we should see the relation between dichromate and I minus. So the rate of dichromate disappearance over 1 equal R minus divided by 6. So 6 rate Cr2O7 2 minus equal rate R minus. Pay attention, the rate of R minus is equal to the variation of the concentration divided by dt, and since I minus is a reactant, we put the sign minus. The rate of disappearance of dichromate equal minus the concentration dichromate divided by dt, and so we obtain also the relation between dichromate and Cr3 plus. By the same way, we obtain the relation between dichromate and I2. So according to the answers, the correct one is A. 6, the variation of concentration of dichromate over dt equal the variation of the concentration of I minus per time. So the correct answer is A. MCQ exercise 1. The rate law expression of the following reaction X plus Y gives Z in the gaseous phase is as follows. V equal K X squared times Y to the power 1. If the concentration of X is tripled and the concentration of Y is doubled, the reaction rate would be increased by a factor equal 6, 9, 12, 18, or 36. So we have a reaction X plus Y gives Z. The rate law expression can be noted V or R equal Kx squared Y. So the reaction is second order with respect to X, first order with respect to Y, and the reaction has a global order or total order equal 2 plus 1 equal 3. This relation, the rate law expression, can be applied at the same time in the same experiment. Pay attention. At the same time in the same experiment. I could not put in this relation X from experiment 1 and Y from another experiment 2. They should be in the same experiment at the same time. I can say, for example, the rate of the reaction at 5 minutes equal K, which is rate constant depending on temperature, equal the concentration of X at 5 minutes squared times the concentration of Y at 5 minutes to the power 1. In other experiments, suppose I did another experiment for this reaction, the partial orders are the same since we have the same nature of the reaction. So the partial orders are specific for the reaction. K, I explain. I did not answer the question till now. I explain what is the rate law expression. K depends on the temperature applied in the same experiment. And since in the same experiment for the same reaction, when the reaction starts, we could not change the temperature. So the rate of the temperature of a certain experiment is constant. For this reason, K is called the rate constant. When X is tripled and Y is doubled, at which time? When my reaction starts, pay attention, we could not do any external effect to X and Y. When the chronometer starts, we could not intervene in our reaction. So in this question, when X is tripled and Y is doubled, it means at T equals 0. Or in other words, suppose you start an experiment, another experiment. If you start in experiment 1 by X, in experiment 2, you start by 3X. And if you start in the experiment 1 by Y, concentration of Y, you start in the second experiment by 2 concentration Y. So we can change the concentration at the starting of the experiments. The rate law expression is applied in experiment 1 and is applied in experiment 2. So R prime, R equal, V equal Kx squared Y. V prime or R prime, we multiply the concentration of X by 3 and Y by 2. So 3 to the power square, 9 times 2 equal 18. So now we are at T equals 0. So we can cancel X and X, Y and Y, K and K, and we obtain a factor 80. So when the reaction, when the concentration of X, suppose the initial concentration of X is this term, the initial concentration of Y is this term. In the second experiment, we have 3X value, 2Y value. Okay, so you can cancel and you obtain the ratio 18. So the rate of the reaction increase by a factor 18, pay attention, at t equals 0 and not another time. I will do a summary. I have a reaction. In the first, I start by a certain value of X. I noted concentration of X and concentration of Y at t equals 0. In the second experiment, I start by X 3 times. I will note it 3X, and Y 2 times. I will note it 2Y. Then I start the two reactions at the same time. I can compare these two reactions only at t equals 0, because the rate of the reaction 1 decreases with time, the rate of the reaction 2 decreases with time, but these two rates are not equal. So I can compare only the rates at t equals 0. And the initial rate, when you double Y and triple X, increase by a factor 18. The answer is D. MCQ exercise 2. For a reaction, the rate constant depends on the concentration of the reactants, the concentration of the products, the temperature, the order of the reaction, C and D. We know that K is given by the relation K equal E minus EA divided by RT. For the same reaction at T constant, EA is constant. Okay, so K is temperature dependent only. It does not depend on the concentration of the reactants, nor in the concentration of the product. And in the slides, I explain the dependence of K on the activation energy. K does not depend on the activation energy. The activation energy for a certain reaction is constant. If you add catalyst, for example, you change the activation energy, but you change the nature of the reaction. So K of the catalyzed reaction is not the same as K of the same reaction non-catalyzed. So as a conclusion, K is only temperature dependent. K depends on the nature of the reaction. Two different reactions have different K. For the same reaction, K is only temperature dependent, and the answer is C. MCQ exercise 3. For a certain reaction, if the temperature increase, T half increase, T half decrease, T half is constant, the yield of the reaction increase, and in part B, in answer E, we have two possible answers, B and D. We know that the half-life is a specific time of the reaction. The half-life depends on the rate of the reaction, and it depends on the nature of this reaction, and it depends on the initial quantity of the limiting reagent. You have, by definition, is the time needed to convert the half of the limiting reagent or to form the half of the final product. And we know also that two experiments of the reaction at the same initial concentration but different temperatures, if we realize two experiments at the same initial concentration but different temperature, should we have the same T half? No. If the two experiments are at the same initial concentration and the temperature are different, the rate of the reactions are different. The temperature is a kinetic factor, increase the rate of the reaction. I explain only. Okay, I will treat now each part. What would happen when the temperature increase? When the temperature increase, we suppose in this problem we change only the temperature of the experiments, but the initial concentration are the same. When the temperature increase and the initial concentrations are the same, the rate of the reactions are different. And the temperature is kinetic factor. So as the temperature increase, the rate of the reaction increase. When the rate of the reaction increase, the time to reach the equilibrium state is less. And the equilibrium state is T equal infinity in case of the complete reaction, or T equilibrium in case of the incomplete. So in this case, when the time to reach the equilibrium state is less, and we have the same initial concentration in these experiments, so necessary the half-life of the reaction will decrease. So the answer is B. Exercise 4, MCQ 4. For the reaction H2 as gas, O2 gas, as solid, H2O liquid, which of the following statements is true? The reaction is order 1 to H2S and order 2 to O2. The reaction global order is equal to 4. The rate law expression is given by R equal KH2S square O2 or H2S O2. Or the rate of the reaction, the rate law cannot be determined from the information given. We know that to find the partial orders of a certain reaction, we need to do experiments. And we have several methods in the lab to find the partial orders, then to deduce the global order. Method 1, which is the log plot. Method 2, which is the ratio technique. Method 3, which is the integrated rate law. Method 4, the unit of K. Method 5, T-half. So according to the data given, we could not know or determine the partial orders of the reaction M and N. So the information given could not determine these partial orders, and the correct answer is E. Suppose in this exercise we have the term elementary reaction. If he gave us indication that this reaction is elementary reaction, that means takes place in one step. Thus directly we can relate the stoichiometric coefficients of H2S to the partial order with respect to H2S, so M equal to, and the stoichiometric coefficient of O2, 1, to the partial order with respect to O2, which is equal to 1. So only in the case of the elementary reaction we can deduce directly the partial orders, and this is not the case in this exercise. MCQ exercise 5. The integrated rate law for the following first order reaction A2 product is, we have several possibilities. We know that the first order reaction of the type A2 product, the integrated rate law, we proved the integrated rate law, ln AT minus ln A0 equal minus KAT, or we can write ln AT over A0 equal minus KT. So AT divided by A0 equal E minus KT. and therefore the concentration of A at time t equal the initial concentration of A, E minus KT. So the correct answer is B. MCQ exercise 6. Consider a second order reaction of the type A to product. Pay attention, the type is very important. We have to distinguish between A to product or AA to product. A straight line is obtained for the plot. For a second order reaction of the type A to product, the integrated rate law of A is given according to the relation 1 over AT minus 1 over A0 equal KT. So 1 over AT equal KT plus 1 over A0. This is the equation of the straight line. If we consider, for example, y equal 1 over AT and t equal x, 1 over A0 equal b. So this is the equation of the straight line y equal ax plus b. For the second order reaction, this relation is justified. So the equation of the straight line is justified. So if we plot 1 over concentration AT as a function of the time, we should obtain a straight line. So we plot 1 over AT as a function of time, and the correct answer is, in this case, C.